All right, hey everyone, my name is Gabe and I'm going to be doing my presentation on East Java eruptions in 1919. So the setting of the event, it happened May 19th, 1919 at the Mount Kelud and surrounding areas in East Java, Indonesia. And what happened, it was a major eruption of Mount Kelud and the ensuing Lahar flow, which I'll explain in a second. So, series of events. The eruption of Mount Kelud triggered a massive lava debris landslide called Lahar flow, and they were caused due to Mount Kelud displaying a 40 million cubic meter crater at the top, which was filled with great volumes of ash, mud, and water. So, when this volcanic material mixed with the materials at the top of the crater, it caused these lahars to form. Um, and they're also called volcanic mud flows, and they traveled at speeds of up to 37 miles per hour, which is pretty fast. And the lahars reached Blatar in less than an hour, which is a city almost 20 miles away. So many villages in between were also destroyed. And how is this significant to me? My great grandfather lived in Indonesia at the time. He lived in West Java, and since this is East Java, he didn't really experience um, the effects of the lahar or the eruption, but he did um, talk to a lot of people that lived in East Java at the time and moved due to just being scared of that happening again or their home was destroyed. So it was a pretty big deal at the time. And lahar is defined as a mixture of hot lava and volcanic material with water and rock fragments that travel down the slope of a volcano. And since Mount Kelud was a stratovolcano, it's pretty steep, so it's easy for the lahar to build up speed. Here's a flat map of East Java, where the eruption happened at Mount Kelud at the crater. And as you can see from the scale, Blatar is um, far away and it still was affected by this flow. And we can conclude that even though the eruption wasn't that big of a deal, miles away, the Lahar flow was affecting towns and cities. The nearest big city was Blatar that was affected, but numerous small towns were wiped off the landscape. One witness tells us in Blatar that only the houses of brick walls that coincided and were hand in hand were not so damaged, but the walls were broken down. So even the really sturdy brick wall buildings were destroyed, and so the flow wasn't something you can survive if you're in it. So a little look at the tectonic plates. So Indonesia is located at a convergent plate boundary, which explains the presence of many mountain ranges and volcanoes such as Mount Kelud, which are formed at subduction zones. East Java is located on the southern edge of the Eurasian plate against the Indo-Australian plate, as you can see at the left side of the map. And Mount Kelud is part of the Ring of Fire, which I'll show a picture of in a second, and more specifically part of the Java Trench. And relative plate motion. So it's approximated that it moves 5 centimeters to 7 centimeters each year. So I'll show you a picture um, of the area closer up. So in this image, they estimated a 7 centimeter relative plate motion. So this is kind of why I think the 7 centimeter is a bit more accurate since it's dealing with East Java specifically, where it's measured. And the rates typically vary from 0.6 centimeters to 10 centimeters per year. So 7 is on the high end. Type of plate boundary that we're talking about. So East Java experiences a convergent plate boundary. So the forces that it's kind of feeling are pressure, compression, and friction. Um, and these forces are often what cause volcanoes to be made and earthquakes to start. So these forces are due to the fact that the plates are colliding um, instead of moving apart like we see in divergent and they're not sliding past each other like we see in transform. So we're dealing with a reverse fault, which form at convergent boundaries, and they result in shortening. So as we can see from the visual, reverse fault kind of looks like one side is maybe subducted while the other is being pushed up. And you can see the compaction. So how do these landforms in East Java region form? So this picture does a good job showing you how there's an ocean, and the oceanic crust is being pushed down the lithosphere into the asthenosphere, and along with it some water, which is why this visual is pretty good. And the continental crust is being built up due to the magma chambers and the magma flowing up. So due to the subduction of the Pacific Plate, East Java and its stratovolcano Mount Kelud are among the Ring of Fire. When oceanic crust is at a subduction zone, it is melting and pushing down into the below the continental crust, as we see in the picture. And new continental crust has always been created via the force combined with magma flowing up to solidify into granite. And volcanoes are formed similarly to mountain ranges in this area due to the convergence of the Eurasian plate and the Indo-Australian plate, causing oceanic crust to subduct and build up continental crust through magma flow. And yeah, as we can see, I made a little note. It shows the water being subducted, which allows to superheat the lava and thin it so that it can easily rise and form continental crust. Landforms near Mount Kelud. So here's that picture of the Ring of Fire that I was talking about. And along the Ring of Fire, there's a lot of volcanoes and mountain ranges. So there's too many to list, but some very nearby volcanoes are Mount Bromo and Mount Semeru. And mountain ranges nearby are Mount Kauai and Mount Gunung. And then obviously there's a lake, a crater lake at the top of Mount Kelud, along with, so the Indian Ocean is the southern border of Indonesia. And this picture, or these pictures, do a good job showing like how we see these mountain ranges and volcanoes so close together. And this shows the island topography and shows Mount Kauai, which is very close to Mount Kelud in East Java. So rocks in East Java, we're dealing with primarily andesitic rocks, andesitic volcanics. This is indicative of the presence of oligoclases and feldspar, and it's also indicative of the 55 to 65% silicon dioxide content. And we can see in this chart the relationship between silicon dioxide content and what the content is, and temperature and viscosity. So obviously as temperature goes up, viscosity gets lower because as it gets hotter, obviously. So andesite rocks are almost exclusively found at subduction zones. So where we are is a subduction zone. So this isn't out of the ordinary. And this is because the oceanic crust subducts and it melts to form magma, which eventually rises. And when the volcano erupts, the lava is spewed throughout the region. And once it's cooled, andesitic rocks are formed. So here's a list of earthquake and volcanic activity historically. There was one scare that the Tambora volcano was going to erupt again. As you can see, the 1815 eruption of Tambora was very deadly and very catastrophic. So the increase in seismic activity was a bit of a scare, but recent scientists have said that usually another eruption from the same volcano this big would take hundreds or thousands of years to happen again. So also on this chart, we can see the Mount Kelud historically. So obviously it happened in 1919 is what I'm talking about. There was 5,000 plus casualties. And Mount Kelud also erupted in 1966 and in 1990 and in 2014, which isn't shown on this. because it had a relatively low impact. Um, so Mount Kelud is pretty active, according to this. So events of the 1919 eruption in order. So we're talking about Mount Kelud 1919 eruption again. A convergent plate boundary eventually caused a subduction zone, which gave rise to a volcano. And after the gases were built up inside the volcano's magma chamber for years, the gas pressure built to a point that it met threshold, and it exceeded threshold, and the gas forcefully escaped through the conduit and out of the volcano's vent. And because there's a crater at the top of the vent, all the contents of the crater, which was water, ash, and mud, was spewed out and mixed with the volcanic matter that was produced through the eruption. And this crater was so full, lahars formed and built momentum as they traveled down the steep sides of the composite or stratovolcano. These lahars were extremely hot and extremely fast. So not many obstacles could stop the flow without being destroyed. And as I said earlier, villages and cities 20 miles away from the volcano's crater were affected by this destructive mud flow or lahar. So I explained kind of why the East Java incident happened and how volcanoes kind of formed, but why was it so bad? So the lahars were what caused the incident to be so deadly and destructive. Lahars occurred because the volcano, its crater was full of volcanic material already. So once it exploded, the ash and water near the top of the vent spewed out, like I explained earlier. And this picture is just what lahar looks like. And as you can see, it kind of, I can't tell if you guys can tell, but it's moving fast. Um, and you can see that it doesn't look like a regular magma flow, and it doesn't look like a landslide. It's a thing of its own. So history of events in Indonesia. So before 1919, the Mount Kelud eruption, Tambora event was the worst lahar incident. But it also was just a terrible eruption in general, and it also was associated with a tsunami in 1815. So this event was much worse. Um, so the VEI was 7 out of 8, which is extremely high, and the main reason it was so deadly, unlike the Mount Kelud eruption, it was due to the gas that clouded the atmosphere, and people note it as a year without a summer. So it affected places outside of Indonesia, and it just caused a cloud of ash to be over many people in many cities. Um, and after this event, there weren't any Indonesian volcanic events that caused 5,000 plus casualties besides the 1919 Mount Kelud eruption and subsequent mud flow. So this is why I associated the two together. And after 1919, Mount Kelud erupted again in 2014, and the VEI was 4, so it was similar, but the destruction and casualties were much lower. And this is obviously to do a little bit, at least, with an innovation that has happened since then, since the 1919 event, which caused 5,000 plus casualties in comparison to 4. So similar event frequency. Due to innovation, similar events haven't really occurred, and I'll explain why and how they restricted the lahar from being so deadly. But similar strength eruptions have occurred. So the strength has been similar, but they're just better handled, leading to better outcomes for people in Java. The 1919 Mount Kelud event is the most recent Indonesian volcanic event to cause more than 5,000 casualties, as I said before. So recent eruptions have had very few to none. And Indonesia is always having eruptions, but usually they're not talked about because they're not too impactful. And yeah, there's numerous Indonesian eruptions even in 2021 that have been a VEI of 3, but just they haven't had the same impact. So what have we learned from the event? So geologists learned how to predator protect close civilizations from lahar flow. using better warning systems, quicker evacuation, and better dams to restrict the lahar flow from populated areas to other unpopulated areas, or to just keep it still. And to prevent lahar flow before 1919, it's interesting. So they tried to construct a dam. It was called the Bladak Dam. But following the eruption, it was completely demolished because the lahar flow was so fast. But um, so in 2014, an article compares kind of the successes and failures that geologists and scientists have had with lahar flow to better protect populations. And it speaks about the 27 eruptions of Mount Kelud, since it is a crater, or it has a crater at the top of it. So engineers and geologists learned that they could actually drain the lake using siphons to reduce the number and severity of lahars. Because if you reduce the contents of the lake, obviously the lahar is going to be much less. So this is how they're managing to have way better outcomes after this 1919 event. So adaptations that have been made. So much of the population around 1919 has since moved to west, like Jakarta, where my grandpa grew up, and Central Java, anywhere besides West Java. Some have decided to stay, and they've also had better outcomes just because of innovation. So better warning systems have been put in place to, using enhanced technology. So they're measuring gas emissions using CoSpec, which we see right here. And one cool thing I thought was they're flying planes over the volcanic or the volcano and measuring gas emissions over it using sensors. And to measure ground deformation, we see a lot of different tools being used. EDM, leveling GPS, and tilt. EDM is kind of like a surveying tool. So they're reflecting back to the device using a mirror, which is kind of interesting. Making sure that the ground isn't swelling, which is indicative of usually volcanic activity underneath. And determine how much lava is moving underground. VLF, EM31, and thermal cameras. So I showed a picture of what a thermal camera would look like, and how they're using it to measure temperature with a camera, which is interesting. And obviously there's a bunch of other tools that geologists use that are very complicated. There's they can measure seismic activity, kind of like earthquakes, and all that. So there's been a lot of innovation. So the possibility of worse events. The Tambora eruption was the largest VEI volcanic explosion in Indonesia with a VEI of 7, as I said earlier. So we do not expect any volcanoes in Indonesia to reach the 7 anytime soon. Chris Newhall said that could be hundreds of years down the road that we see another eruption of 7. But he's just talking about generally in the world. And he goes on to say that it could possibly be in our lifetimes. But so going on with the Tambora eruption, some were concerned about its eruption again in 2011, since there was columns of ash measured at 4,600 feet using satellite imaging measurements. So there was also an increase in seismic activity, which is concerning, but it is still last seen to have erupted in 1967. So it didn't erupt in 2011, but even if it did, scientists believe that another eruption of that magnitude is not likely to happen with the same volcano, because usually it takes years to happen again. So the eruptions similar to Mount Kelud's VI of 4 are happening all the time in Indonesia, and it's due to the constant subduction of oceanic lithosphere throughout the Indonesian coastal areas. But obviously the effects are much different than the 1919 one. So here are the references that I used, and thank you for listening.